Hey everyone and welcome to the Retro channel, and today we're doing some mods on the good old Commodore 64. Recently I've been using this 5-pin DIN cable to 4 RCA breakout to hook up a lot of systems via composite and Luma Chroma, or S-Video if you prefer. A lot of the Atari 8-bit computers use a 5-pin DIN, as does the VIC-20, and with my VIC-20 video upgrade board, I actually used the same pinout that Atari used, so this cable is compatible between both of those machines. I've also used this pinout on my recent Atari 2600 video upgrade, the Tiara, so now I have a total of 3 systems that can all use this same DIN connector. But the Commodore 64 is a bit of a holdout because it actually uses an 8-pin DIN on most systems, and the pinout is slightly different. You can see where Chroma is on the other machines. We actually have an audio in, and to be honest, nothing uses that. Maybe some musicians that use the C64 to generate music. Maybe there's some use in it for them, but for most people, they're not going to be using that pin. And to be honest, it's a bit of a liability having that on the DIN connector because say you were to feed the wrong voltage in there, or maybe some ESD, you could end up killing the SID. So what I want to do is actually remove that audio in and replace it with Chroma. That way I can use this cable not only on the C64, but I guess this could also apply to the 128 and all of the other systems that I mentioned. But before we go just disabling that audio input, I do want to have a little play around with it because I've heard that actually grounding that input can help reduce some of the background noise that the SID generates. So let's open this thing up, have a little poke around. We'll take a look at how much background noise is actually being generated from the SID and whether it is actually reduced by grounding the audio input. And if so, work out a solution for that, and hopefully at the same time work out how we can change the audio input on the DIN connector for a Chroma output. Right, so this machine is obviously a little bit of a bitzer. We've got a 64C case, a bread bin keyboard, and on the inside there is actually I think this is a 425 board. Yes, a 425 board, which wouldn't have come in these cases. You'd normally see a 466, which is the final longboard version, or a 469, which is the Commodore 64 shortboard. This is actually a machine that I showed a few months back on the channel. In that video, it had the top half of the Aussie 64 case and the bottom half of a 64C case. After that video went out, I actually found the other person who had the bottom half of the Aussie case and the top half of this case. So we worked out a little swap where I sent him the top half of the Aussie case and he sent me the top half of the 64C case. I already have a Aussie C64, so I didn't really need another one. I'd rather have somebody else complete their own Aussie C64 case. But anyway, that's what happened there, and obviously this is still the same board, so I'm guessing it had a bad kernel ROM and a bad SID. Pretty sure there was something else wrong with it, but it was quite a... Oh, I remember what was wrong with it, and it was quite the headache. I won't spoil it, so if you want to watch that video, go right ahead. Right, so there's 3 different tests that I want to run. First one is just establishing a baseline, so just with the machine, just boot it up. How much background noise do we have in this state? And I'm going to do this with the ARM SID, another random SID. This one is slightly damaged. Voice 3 is marginal on this thing, but aside from that, it still works like a regular SID. So I've included this because I'm not too worried if I accidentally kill this thing properly. And finally, I'm going to do the same test with a 6581R4AR. These are sort of the gold standard for SIDs. Whether or not I really believe that, yeah, I'll leave that up to you. So, as I said, first of all is just a baseline test with the machine just powered on, see how much noise we get. And then we're going to set the SID volume register to its maximum, just like that. So it probably still sounds exactly the same. I'm pretty sure the ARM SID has a fairly low noise floor, so not many issues there, but we should see some differences when it comes to the other 2 SIDs. Then I'm going to repeat those same tests with the audio input grounded, so The kind of handy thing about using this DIN cable is this is currently the audio into the SID. So what I'll do is just stick one of these RCA plugs in there, and I've just shorted the signal to the ground pin. So with that plugged into here, we're effectively grounding the audio input. Once again, I'll take a sample with the machine just powered on, so the SID should be basically off at the moment, and another sample with the SID at maximum volume. The final test, which I won't do with the arm SID because I'll end up breaking off one of the legs, is just to bend the audio input pin on the SID out of the socket. So it's pin 26 on the SID, and what I'll do is just bend that out slightly so it doesn't make contact with the socket, and that'll have the effect of basically leaving the audio input floating on the SID. That may also help, may make things worse. We're going to find out. All right, the results are in, and they are interesting. So up the top here we have the arm SID at 0 volume, so when the machine's first powered on, and also the arm SID set to maximum volume, and then the same for an original SID, 0 volume and maximum volume, and down the bottom the R4AR at 0 volume and maximum volume. The first 5 seconds is just having the audio input pin unconnected. The next 5 seconds is grounding that audio input pin on the DIN connector. And the final 5 seconds is bending out the pin on the SID and having the audio input floating. Like I said, I didn't do this for the arm SID because that would just break one of these legs. Now keep in mind I have amplified all these samples by 40 decibels, so normally all this noise wouldn't be anywhere near this loud. Let's start off with the arm SID at 0 volume, have a listen. So yeah, that is basically best case scenario. And to me, I couldn't hear any difference between the audio input just being disconnected and the audio input being grounded. And with the arm SID at maximum volume, it's basically the same story. So yeah, to me, I can't really hear any difference between any of those samples. Let's move over to an original SID. So once again, volume at 0, with the audio input disconnected, grounded, and floating. So there was definitely more of a high-pitched buzz with the original SID, but it didn't seem to make any difference how that audio in pin was actually being treated. Let's have a listen to the SID at maximum volume. So that's when we can really start to hear a difference. It seems just having the audio input disconnected gives us the worst result. And then grounding the audio input makes it slightly less buzzy. But actually bending out the pin on the SID and having the input floating seems to give us the best result. Sure, there's still plenty of noise in there, but keep in mind we've already amplified this by 40 decibels, and normally if the SID's set at that volume, it's actually playing something and not just outputting silence. Let's have a listen to the R4AR, so this will be at 0 volume. So interestingly, the R4AR is a lot noisier than just the original SID. But just like the original SID at 0 volume, it didn't seem to make a difference how we actually treated the audio input pin. But let's see what happens when the volume's set to maximum. So I think you'll agree that's very similar to what we got with the other SID at maximum volume. Having the audio input disconnected seemed to be the noisiest. Grounding it sort of improved that a little bit, but actually bending out the pin and leaving it floating seemed to give us the best results. So I think what I'm going to do with all my SIDs from now on is just bend out pin 26. It seems to reduce background noise, and there's no real downsides. In fact, having it not present on the DIN connector all the time is probably another way to protect these SIDs from accidentally being zapped. Now things are going to be a little bit different when it comes to the Shortboard SID, the 8580, and that is to do with digital samples, or how the Commodore 64 generates digital samples, but we'll get to that in a moment. Let's first of all modify this machine to replace the audio input on the DIN connector with a Chroma output. So to make sure I'm looking at the right pin, let's just measure from here, which would currently be hooked up to the audio input, to the underside of the DIN connector. And that's our audio in right there. That's kind of handy because right there is our Chroma output. So we just need a little bodge wire between here and here. Now, although we've already disconnected the audio input to the SID, I am just going to cut this trace as well, just to make sure the Chroma signal doesn't flow back through here, because the Chroma signal will flow back to this resistor here, which just goes to ground. It is 100K, so it's not really going to affect the Chroma signal, but it also goes through this 100 nanofarad capacitor here and over to the audio in on the SID socket. This is here because the audio in pin actually has around 4.5 volts DC offset on it, so it basically blocks DC from going out through the DIN connector. And I guess if you were using that external audio input, this would block any DC being fed into the SID chip. That's also the reason why you can't just ground this pin directly, because there is a voltage there. So if you do that, you'll probably end up killing the SID entirely. So while I could just bridge these two pins, if I ever put another SID in this machine and don't bend out that audio input pin, then I'm basically going to be sending Chroma into the SID. Probably wouldn't matter either because it's a high frequency signal and it doesn't have a lot of voltage on it, but it's probably not a good idea either. So I think the two options I've got are to lift the legs on both of these, or alternatively just cut this trace. Now I know a lot of people don't like cutting traces, so let's go with the lifting of the legs that do not want to lift out easily. Come on, there we go. There's the resistor out. Right, with those two components out of circuit, we've basically isolated this audio input pin, and even if I do put a different SID in here and forget to bend that leg out, still nothing's going to happen because these two are not installed. So let's bridge these pins. So we're going to go from the center to that pin right there. And I'll just use a component leg offcut to bridge these. That'll do. Alright, that's it. Our mods are done. So now I can use this DIN cable, which I've been using for a bunch of other things, with the Commodore 64 as well. And as a bonus, we've also reduced a bit of noise from the SID. Probably should make sure everything still works as expected. Let's just quickly test composite video and audio, make sure they are still good. Yep, cool, no problems there. Let's swap over to separate Luma Chroma, or S-Video if you prefer, which will now be those two. We'll use that for audio. So on the RetroTink, you can actually use the RCA jacks for S-Video, or you can use the S-Video connector. I do have a cable that goes from 2 RCAs to a single S-Video plug, so that's always an option for things that don't have separate RCA jacks, but generally I'm using either the RetroTink when I'm making one of these videos, or if I'm actually playing something, I'm using one of the Commodore monitors, which has separate Luma Chroma on RCA jacks. So this kind of works out really well for basically all the display devices that I have. So we'll just set the RetroTink to S-Video green and blue. Let's see, we should have color. Yes, perfect, cool. That means, yeah, this cable is pretty much compatible with a whole number of systems that I have. Obviously, I could have just used the direct S-video output from my RF replacement, but it's nice to just have other options, and I always have this cable close at hand. Now that does make me wonder if just removing these components gives us the same results as bending out that pin. I guess a little bit of the noise could be caused from just the traces running over to this capacitor, so maybe there will still be some noise if we bend the pin back in, but well, there's one way to find out. Okay, well, this is really interesting. I just took a couple more samples, and as you can see, this one stands out quite a bit. So this is just the R4AR. These first three are the same samples we looked at before, so minimum and maximum volume. But this section here is where I straightened pin 26 and stuck it back in the socket. And yeah, you can see there is a very big difference here. Actually double checked my work and bent the pin back out again to take another sample, and everything went back to normal. So mind your ears, because we're going to have a listen to how it first sounded when I bent that pin out, how it sounds with the pin straightened, so going back into the board and these two components removed, and then how it sounds again with the pin bent out and these two components lifted. You'll notice it's actually clipping here because I applied the same amount of amplification that I did to the rest of the samples. And I didn't expect that to happen. But yeah, that is definitely an accurate result. I triple checked my work on this one. I suppose just the little bit of trace going from pin 26 over to this capacitor and not having anything connected on the other side is enough to turn this into a pretty decent aerial. So that makes me think that I should have just left these components installed and cut the trace instead. At least that way, if I don't bend pin 26 on the SID out, we're not going to introduce a whole bunch of extra noise. Right, components reinstalled, and yeah, that trace is definitely cut right there. So I can always bodge that back together, but I don't think I'm ever going to want to do that. Let's try it one more time. And after running those tests again, you can see everything is pretty much back to normal. So this last sample here is now with the pin going back into the board, these two components reinstalled, and the trace cut towards the DIN connector. So this sample here should be pretty much the same as the very first sample because it's kind of a similar setup. Let's have a quick listen. And how it sounds now. So it sounds like there's slightly less noise, but that's probably because we've reduced the trace length from going all the way out to this point here to stopping around here somewhere. Still nowhere near as good as just bending the pin out on the SID though. Yeah, okay. So I think there's two things we've learned here. First of all, if you want to reduce the noise from a longboard SID, the best method seems to be just to bend out pin 26. The second thing we've learned is if you want to reuse the DIN connector to output Chroma using a 5-pin DIN cable, cut the trace from the audio in and put a little bodge between Chroma out and audio in on the DIN connector itself. That way you can use these types of cables, which are really easy to find. You don't have to stuff around with trying to find these 8-pin, I think they're 262 degrees, horseshoe shaped DIN connectors. You can just use these much more readily available 5-pin DIN to 4 RCA jobs. But like I mentioned, things are a little bit different when it comes to the Shortboard 64s and the 8580 SID. So let's grab one of them. Right, so here is my Shortboard machine. So if we pop this open, get all this stuff out of the way, I think the first thing to do with this one is just remove that audio in from the DIN connector and route Chroma there instead. So let's get that done, and then we'll deal with what to do with the SID. Right, so once again, I'm just going to cut the trace going to the DIN connector for the audio in. I might do that just around this part here. This board has already had a whole bunch of modifications done to it, so it's not the only trace that's been cut, and well, at least some of them have been reconnected. This is the only shortboard that I have, so I did a lot of testing with my RF replacement on this particular machine, so it's seen a lot of action. Let's just make sure that's cut correctly, so it's that pin, and it should go somewhere there. Yeah, so it's definitely cut from this side. So now all we do is just stick a little bodge between the center pin and that pin right there. Right, and with that, the audio in should now be a chroma out. Let's give it a quick test. Oh, no chroma. Why no chroma? Oh, because I haven't set the input on the RetroTink to the right one. Whew, that's better. All right, that part is done. Now, when it comes to dealing with the SID, the 8580 in the shortboards is a little bit different, and that's mainly due to digital samples. Well, I guess they're not even really digital samples. It's a way of creating what sounds like digital samples, and this is used by a lot of games like Impossible Mission. Another visitor. Stay a while. Stay forever. And Ghostbusters. Ghostbusters! So those speech synthesis parts aren't actually something the SID can normally do. It was a little trick by developers to actually turn the SID on and off rapidly, and if you do that at a certain frequency, you can create what sounds like digital samples. But with the 8580, they actually corrected that bug with the SID, so it no longer makes a little popping sound when it's turned on and off rapidly. So all of those things are effectively broken. There are also a number of games that relied on that trick, and a good example is the Skate or Die intro by Rob Hubbard. So that's what it sounds like with the 6581. However, if we play that on an 8580, so yeah, the music definitely sounds different. Obviously we don't have that sort of guitar riff, I guess you could call it. You can hear the sort of parts where that's happening. The actual SID tunes, the thing that it's supposed to be playing, also gets a little bit quieter because the SID's rapidly being turned on and off at the same time. Of course, similar thing happens with Impossible Mission. And Ghostbusters as well. Now, like I said, the reason all this happens is because the 8580 actually corrects a bug in the older SIDs that caused them to pop, basically, as they were turned on and off. So if we fire this thing up, we can do this in BASIC as an example. So if we just poke the SID volume, we'll do a quick little program just to poke it to its minimum and maximum volume, and then we'll just loop that. So all we're doing is turning the SID on and off rapidly, or at least as fast as BASIC can do it. But you can just faintly hear there is sort of it's almost like a buzz. If we do that same test with a 6581 SID, yeah, it's obviously way louder. Thankfully, there is a way to get the 8580 to sound the same, and I don't really know who discovered this or how they came up with it, but it has to do with the SID audio input once again, and somebody discovered that if you put a high value resistor between pin 26 of the SID, which is the audio input, and ground, that popping sound will actually return, and therefore digital samples will work once again. It seems a value between sort of 150 kilo ohms and 1 mega ohm seems to do the trick. The lower that value, the louder the digital samples get. So let's try it out with 150 kilo ohms, see what it sounds like. So I'll do this the quick and dirty way. We'll just get ground from here, and I've got a 150 kilo ohm resistor. We're going to touch the other leg to pin 26 of the SID. But first of all, let's just set up that little program to turn it on and off. We can do even stick a go to there. Right, so at the moment it's very quiet. Let's touch this to pin 26. And there it is. That's possibly a little bit too loud. So let's go up to say 330k, see what that does. Yeah, that sounds pretty similar to what we heard with the shortboard. Let's try that out with an actual game. I'm just going to stick the resistor in next to pin 26, so that should be fine for now. Another way to do this obviously is to get like a 1 mega ohm trim pot and then just adjust it to where you think it sounds right. But let's load up a game, see how that went. Oh, actually need a device to load a game from. Well, I don't know about you, but I think that sounds pretty close to what we heard with the 6581.
Another visitor. Stay a while. Stay forever. Ghostbusters!
Yeah, I'd say that volume level is just about right. But before you just go using a 330k on all your SIDs, you definitely want to test this for yourself, because different SIDs will output a slightly different volume level. So even with the 6581, some SIDs will have louder digis, and some SIDs will have quieter ones. And the same goes for the 8580, which is why, 150k to 1 mega ohm is recommended, and then you can dial that into whatever sounds correct to your ears. So we've figured that part out. We're going to use a 330k between the external audio input and ground. Obviously, this will have the effect of the SID making little pop noises when, whatever software is running tries to adjust the volume output of the SID. That is why it's considered a bug, and I guess why Commodore corrected that, but I'd rather be able to have those digi sounds being played back at a normal volume level and, suffer from a few occasional clicks and pops where there shouldn't be some. Of course, this changes things when it comes to the noise reduction mod, because now we can't just lift pin 26 out of the socket. We need to have that resistor in place, otherwise we're not going to get the proper digi playback. So the way most people perform this Digifix mod is just to put the resistor between the left leg of C79, that's the leg going to the audio input on the SID, and the right leg of C39, which is just connected to ground. And you can probably notice that I have soldered to those legs before, because of course I have experimented with this mod in the past. But I never got as far as testing out different noise reduction techniques. So let's throw this resistor in, because in theory doing it this way rather than having this long ground lead should at least pick up a little less external noise. Let's plug all this back in. Alright, so our mod is still definitely working. So let's grab a few samples of the SID at 0 volume and the SID at maximum volume like we did previously, see what the noise floor is, and then we'll experiment with lifting out pin 26 of the SID and soldering this resistor directly to it, and obviously the other side to ground, see what kind of difference that makes to any background noise, if any, and go from there. Right, the results are in. So we've got the 8580 at 0 volume and maximum volume. This is where we had it before with that resistor between C79 and R39. And the second sample is with pin 26 bent out and the resistor going to the right hand side of C39, effectively ground. Let's have a listen at 0 volume. Okay, so doesn't seem to make a difference either way, but we can clearly see even just from the waveform at maximum volume, there is definitely going to be a difference here. All right, so once again, I think that confirms that the best solution is to actually bend out pin 26. The only difference is for the 8580, if you want those digital samples played back correctly, then you're going to need to install a resistor from pin 26, so solder it directly on there, over to ground, which yeah, the easiest place to find that is on the right-hand side of C39. So I'm going to tidy this up a little bit. In fact, before we do that, we should make sure that our digital samples are still working, because maybe this cap at C79 plays a role in that. Like I said, I don't really understand why this resistor brings those sounds back, but it does. So let's do the same thing and just turn the SID on and off a little bit. Oh yeah. They still work just fine. Okay, so I'm gonna yeah, tidy this up a little bit just so this resistor is not floating around in the air. Maybe that'll also reduce a little bit of noise, because I guess it is kind of a tiny little aerial at the moment. So let's get this board out and I'll tidy this up a little bit. All right, there's our mod done. So pin 26 is bent out of the socket and our resistor is soldered to the top of pin 26 to the right-hand side of C39. Obviously that means if I ever want to take this SID out, I actually need to desolder the resistor first. Otherwise, you know, you risk ripping pin 26 off entirely. But I only have one shortboard and I only have one 8580, so I don't think that's going to happen anytime soon. So maybe a better solution for this is to design a little PCB that has a socket for the SID to go in and obviously disconnects pin 26 from the main board, and instead route pin 26 through a resistor over to ground, which I think is pin 14 on the SID. That would have the effect of, you know, accomplishing all these things while still allowing the SID to actually be pulled out of the socket without having a resistor being soldered to one of its legs. Maybe I'll whip something up like that, but I'm not going to do it right now. This is working just fine as it is, but yeah, I guess it would make it easier for other people to try out this mod, and also make it easier for me to remove the SID should I ever need to. Of course, these mods can also be done on the 128, the original flat 128, and the 128D, the plastic case D with the keyboard underneath. They use a 6581, so I guess the mods that I showed on the first machine would apply to that as well. And the DCR 128 with the metal case uses an 8580, so I guess these mods would also apply to that machine. Maybe that's something I'll play around with in the future, but yeah, I think this video has gone on long enough, so we should probably wrap this up here. In fact, before I do that, I should probably put a little label just so I know, you know, what mods have been done, at least to the DIN jack on this thing. Maybe come up with a creative name for that mod too. All right, I think I'll dub this the Audio IN2 Chroma mod. At least that'll serve as a good reminder, even just for me, that this machine is safe to use with one of these 5-pin DIN connectors. And I guess if any of these machines ever get passed on to somebody else, hopefully they can just Google Audio IN2 Chroma and this video will pop up and then they'll understand what this mod was all about. All right, there we go. So at least now I know I can safely use my 5-pin DIN cable with this machine. And yeah, I'll probably end up doing this to all my machines because, well, I don't really have a use for that audio in, and doing the noise reduction mod basically disables the audio in anyway. So it doesn't really make sense keeping it on the DIN connector. But yeah, hopefully anyone else who comes across one of my machines in the future will be able to understand what that label means, and they can always restore it back to stock if they really want to. Yeah, let me know what you think about this video and some of these mods. If you've got any suggestions on anything else you want me to try, let me know in the comments. That is it for this one. Thank you all for watching, and a huge thanks to the people that support the channel on Patreon. If you want to do the same, links to that are down below. You'll get ad-free early access to all videos along with discounts on the new Electron store, and of course help support future developments and future videos like this one. So that's it from me. Thanks for watching. Bye.